Aloha everybody, this is Gigi from Kauai Community College. In this video, we are talking about the derivative of the inverse secant of x. Okay, so that's our function, and we want to know what is dy dx when y is equal to inverse secant of x. Same procedure as you have seen before in the inverse sine and inverse tangent videos. So if y is equal to inverse secant of x, then secant of y is equal to x. We're going to go ahead and take the derivative of both sides. Implicit differentiation will apply on the left-hand side to give you secant of y, tangent of y, multiplied by dy dx is equal to the derivative of x with respect to x, which is 1. Okay? Now, solving for dy dx, we will have 1 over secant of y, tangent of y. Secant of y is just x, so that's not an issue. We want to know what is tangent of y in terms of x. Okay, so we know cosine squared plus sine squared is equal to 1, right? I always pull that one out because I know I can get the one that has to do with tangent and secant. Divide both sides by cosine square. I will get 1 plus tangent square of y is equal to secant square of y. So secant of y will equal to, when you square root, you have a plus or minus. Square root of secant square minus 1. Now, secant is of y is x. So this really is x squared minus 1. That's not an issue. The issue is, do I take plus or do I take minus? What's the restriction? So in order to look at that, we need to look at the y value because tangent of y will depend on what the y value is, right? So let's take a look at the graph of inverse secant of x to figure out this y value here. This is 1 and this is negative 1. So when x is greater than or equal to 1, the angle that we are looking at is in between 0 and pi over 2. So y, instead of theta, I should say y, is in between 0 and pi over 2. Okay, now let's take a look at that on the unit circle. Actually, we cannot include pi over 2. It will just be less than pi over 2. We're looking from 0 to pi over 2, not including the endpoint. We're looking at this, this part on the first quadrant here. And we know in the first quadrant, which is this part right here, sine is positive, cosine is positive, so tangent of y is positive. Okay, tangent of y is positive. Okay, so when x is greater than or equal to 1, tangent of y is positive. Now, when x is less than or equal to negative 1, we are looking at this half right here because the y value goes from negative, go from pi over 2 to pi, right? So we're looking at this quarter right here. And cosine is negative, whereas sine is positive. So we know tangent of y in this part is negative. Okay, so tangent right here of y is negative. So this depends. We have to split it up. We would say if x is greater than or equal to 1, then it is positive. And if x is less than or equal to negative 1, then the tangent of y is negative. Now to address that, and when we go back to our derivative here, we would say the derivative of secant, inverse secant of x is, and I put the absolute value there, okay, to denote the fact that it could be plus or minus, okay? And when is it plus? It is plus when x is greater than 1. We are not going to include 1 because that's going to make the denominator 0. And then it is negative if x is less than negative 1. And there is nothing in between because secant of x is not defined for any value in between negative 1 and 1. So that is the derivative of inverse secant of x. Okay, remember, the derivative of inverse secant of x depends on the value of x. And these are the intervals that we need to look at. And that's going to tell you if the answer is going to be negative or positive. Okay, let's take a look at an example here. Find the equation of the tangent line of f of x is equal to inverse secant of 2x. Okay, so let's go ahead and take the derivative. Okay, the derivative, the inverse secant is that. Okay, now we need to decide, are we going to take the positive or the negative for that? Because absolute value of x could be a negative or a positive itself or its opposite. Which one is it, right? Now we are talking about x being 1 in this case. So we're looking at the x value being 1. When we plug that into here, we will have 2. So in this case, x is greater than 1. So we're dealing with the positive value, okay? Let's just go ahead and write down the solution to that. 1 over, and let's just go ahead and write down as is first, absolute value of 2x, square root of 2x squared minus 1, okay? And then multiply by the inside derivative, which is 2. So really, I could just write 2 on the numerator, okay? And then the 2 divided by this 2 right there, because I could take the 2 outside of the absolute value. So really, it is 1 over absolute value of x, square root of 4x squared minus 1. Okay, now we would say, is this positive or negative? And I already told you that when x is 1, 2x in this case, which is our input, is greater than 1. So we are dealing with the positive value. Okay, so the derivative evaluating at 1 is going to be 1 over, and I'm going to take the positive value, and I don't need to write the absolute value there, square root of 4 times 1 squared minus 1. So this is going to be 1 over square root of 3, because 4 minus 1 is 3. So this is the slope of the tangent line at the point 1 pi over 3. To find the equation of the tangent line, you would say y equals mx plus b. Y is pi over 3. M is 1 over square root of 3. X is 1, and this is b. So b is equal to minus the 1 over square root of 3 over. So you will have pi. I'm going to rationalize as I do, and go ahead and get a common denominator of 3, and that would be pi minus square root of 3. So that is B. So the answer here is the equation of that tangent line is 1 over square root of 3, or you can write it neatly as square root of 3 over 3x plus the y-intercept B being pi minus square root of 3 over 3. And that is the final answer.